various functional group like of E class. Okay, so normally the method of disconnection of a bond takes place the carbon which is attached to an E class functional group. Like for example, we have this structure 1 2 3 4 5, and over here is OH. So if you see you have an E class of these two, so this will be plus, this will be minus, this will be plus, minus, plus. Okay, so both the E class having a carbon which is attached to an acceptor synthon, okay, C plus. So this is known as consonant type of structure. But the structure, if it is 1 2 3, so like this, the structure if it is like this, OH, okay, that time your minus will come over here, and then the structure will become dissonant, where the E class also coming to the minus carbon. Normally E class functional group ended up to a carbon positive. Okay, so this is the things we must know before method of disconnection. So let us go ahead with our next examples. Okay, that is very famous CNS acting drug known as carbamazepine. Okay, if I draw the structure of carbamazepine, those who have referred to our earlier video, they know what I am talking about. So you have an immunostilbene type of structure. These, okay, and you have an uride structure as well. So this is carbamazepine, which act as anti-epileptic agents. Okay, now for going for method of disconnection, we know what are the E class structure. So first E class will be having this particular, okay, fragment. So we'll be having a synthon equivalent structure, this heterocyclic azepine, dibenzoazepine molecule with your COCl2 plus ammonia. Okay, so this is your COCl2 known as phosgene. This is your phosgene gas. Okay, so the next challenge is how to synthesize this molecule. Okay, so if you attach these all three, you will get carbamazepine. So how to synthesize this? So we have again the E class structure, this, and the CN is replaced by CC. So then if you see the disconnection, then I will be having two phenyl group where one NH will be minus, this carbon will become plus. Okay, and this disconnection will be C minus, C minus, 2 C minus. Okay, and will be one hydrogen will be present, as over here on one hydrogen is present. Okay, then I have the carbon over here, which is 2 plus with a hydrogen, 2 plus with a hydrogen. These are the acceptor and donor synthon. So if I wanted to convert them into the synthetic equivalent, so then my structure will be this. So if it is C double bond, so 2 C minus, so I'll go for CH2 MgX, CH2 MgX. Okay, and this is a chlorine, one fragment, and the second fragment will be C double bond OH and NH2. Okay, so first stage you synthesize these two together to get the carbamazepine basic nuclear structure, dibenzoazepine, and then with the dibenzoazepine you combine with phosgene and ammonia. So in GPAT they ask the starting material as a questions. Okay, so like for example, they ask that, okay, which of the one of the following fragment is used to synthesize carbamazepine? So example, you have a ortho aminobenzaldehyde plus phosgene plus ammonia. Okay, then salicylic acid plus phosgene plus ammonia. Okay, then anthranilic acid plus phosgene plus ammonia, like this. So you have to find out the correct answer. So this is one of the synthesis for carbamazepine. Then the next synthesis will go ahead with the topic with the drugs known as chlorpromazine. Okay, so chlorpromazine again is a phenothiazine nucleus structure with a sulfur, nitrogen. Remember, if you do not have a basic understanding about Sython, then this video will be very tough for you to understand. So please go through our earlier video of Sython and then you come back. Then you can understand the retrosynthesis process. Okay, so there's a method of disconnection. One chlorpromazine. This is structure. Okay, drug. So method of disconnection. So I'll be having the structure N minus. So this is Sython equivalent, and this is Cl, Sython equivalent. So these two structure, if they combine together, and they can produce chlorpromazine. The next challenge is how to synthesize this molecule. You simply take this particular structure, okay, and then you add sulfur, okay, and you get the basic structure of phenothiazines. Okay, so this is a challenge. People ask that this is a starting material. What is the starting material of chlorpromazine? So this is your aniline, okay, with N-phenyl group, okay, N-phenyl metachloroaniline, right? So this is a synthesis of chlorpromazine. Now the next synthesis of imipramine. So imipramine structure almost the same with a tricyclic structure with a azepine with double bond, benzene, okay. Then you have the remaining part CH2, CH2, CH2 and 2-methyl group. Okay, so again the method of disconnection will be simple form, this NH and the Cl. This is Sython equivalent or reagents that can be used. Then after that, to synthesize this, okay, you can have a multiple steps. You can take this, okay, this NH2, okay, and for starting material, if you disconnect this everything, okay, disconnect, and you will get NH2, that is CH2MgX, CH2MgX, and on the other side it is aldehyde and NO2, aldehyde and NO2. Why NO2? Because after that we'll having a functional group interconversion, NO2 to ammonia, and when ammonia gets formed, during the ring closure, one of the ammonia molecule leave. That is because in ammonia NH3 plus can be a good leaving group. We have already discussed. So that's why basic chemistry knowledge also very important before we go for Sython. So that's why I never teach this Sython CNS in an earlier stage of Growwell education, because otherwise students will think that I'm not understanding, I'll not join the class. Okay, so many times it's happened that we have got a highest number of NIPER qualification in Mumbai for last 5-6 years at least. Okay, highest number of people qualified in GPAT and NIPER in a ratio wise. But when you're talking about the teaching, so I would like to prefer to teach these subjects later part in a pharmaceutical teaching than the earlier parts. Okay, so after that you have the next drug of synthesis, that is your doxypine. So doxypine, I have told during my CNS video, doxypine is a congener of the famous drug amitriptyline. Okay, sorry, this is amitriptyline means it is heptadine, heptene with an oxo congener. So double bond CH, CH2, CH2, and CH3, CH3. So how to go for that synthesis? We go for first functional group interconversion, where this can be this can be seen in this particular format, the FGI from the doxypine. Okay. Then after that we go for method of disconnection, that is over here. Okay. So then we'll be getting Sython. The CH, this is a plus and this is minus. Okay. Right. Yes. So when the moment you get plus over here, as we know that our chart what I have mentioned, that I can draw a ketone over here